Alright, so we're gonna, whatever you did not finish on that first page will be part of your homework, okay? We're gonna now move into maybe learn about some things that you haven't seen before. And the first thing is what a factorial is. So if you see a number with an exclamation mark, like here you have n with an exclamation mark, it is not n, not what it is. It is n factorial, which means you take that number and you multiply it with all the integers below it. So if I say 5 factorial, find 5 factorial, you say, well, that's 5 times 4 times 3, and you keep going all the way till you get to 1. You list them all, and you have to multiply them all together. And so in this case, that would be what? 120, right? So that's what we mean by factorial. And so we have some problems here to try out, just to get used to factorials. I'm going to do number 1 with you. Number 1, we have 28 factorial over 26 factorial times 36. And I want you to do as much of this without a calculator. So this one right here, try to do without a calculator, if you can. Now, when the numbers get really big, then don't do them. But with fractions, we can reduce, right? And so 28 factorial means 28 times 27 times 26 times 25. And I'm not going to list them all out because it keeps going down. And then you get the last bit here, right? So it goes, so you have 28 factors here that they want you to multiply together, and that would be really large, right? Now 26 factorial, here's the thing I want you to start to recognize. 26 factorial is 26 times 25 times 24 all the way down 1. And then we have a 36. So a lot of the factors will reduce. And all we're left with now is 28 times 27 over 36. Now again, if they don't use a calculator, you're not going to want to multiply things together because that makes it bigger. You want to break things down into smaller factors so that you can continue to reduce, right? So for example, you could say, well, 28, if I divide that by 2, I get 14. So I divide 36 by 2 and I get 18. I can divide 14 by 2 and get 7. Divide 18 by 2, I get 9. I could divide 27 by 3 and get 9. Divide 9 by 3 and get 3. Right? Divide 9 by 3 and get 3. Divide 3 by 3 and get 1. So this becomes 7 times 3 over 1. This is 21. Now if you went and typed in 28 factorial into a calculator, some calculators may not even be able to handle that number. It'd say like overflow, or this I can't hold this number, it's way too big for me. Some of your calculators will be able to handle that number, but they'll put it in scientific notation, which may not look familiar to you. And then others may show it to you. But well, some of you are trying that, but we'll look at that a little later, though. Okay, so you got some really big numbers there. So some of these are better to do without a calculator. If you have a scientific calculator, you may actually have a factorial button, and you can look into that. Or you may have a button that says probability, PROB, and under that you can see the factorial. Just depends on your calculator. But these right here are meant to do without a calculator. Let's take a look at number 4 now. Number 4, you have 3 factorial times 5 factorial times n factorial is equal to 10 factorial. You just got to figure out, well, what should n be? It's got to be an integer. It's not going to be a fraction. Not too many choices out there. So see if you could figure that out. Try to solve for n. Like an inverse of factorial, is that what you're meaning? Okay. What are you guys trying here on number 4? Condense it down to a factorial? There's no button for that. What are you guys trying though? What's the first thing? Yeah. Okay, so starting by like divide both sides, right? So you have a 10 factorial over 3 factorial, 5 factorial, like that? Is that what you're thinking? And so, again, I'm going to tackle this without a calculator. So this is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 3 factorials, 3 times 2 times 1. 5 factorial, 5, 4, 3, 2, 1. And then start reducing. 3 times 2 is 6. So 3 times 2 times 1 is 6. So that can reduce 6. So now I get n factorial is equal to 10 times 9 times 8 times 7. Okay. Now, at this point, it's a little more challenging, right? Because you're like, well, what factorial is that? And what I think would be helpful to do is to break down your factors more to more, because right now I don't see what it is. And so I'm going to break the 10, the 9, the 8 down. 7 you can't break down. So you know it's got to be 7 factorial or more. So here's what I'm going to do. I'm going to write n factorial is 10 is 2 times 5. 9 is 3 times 3. 8 is 2 times 2 times 2, and the 7. And then I'm going to start seeing what I can make. Okay, obviously this is 1 times something. So I'm going to start working my way up. So 1 times 2, so I'm going to use that 2 right there. Times 3, I use that 3 right there. Times 4, so let's see, I need the 2 2's to get the 4, times 5 right there, times 6, that's the 3 and the 2, times 7. Now I've used them all. Why did I do that? Well, because factorial is some number all the way down to 1. It doesn't miss anything. And so I started at 1 and started working my way up and to see what this is equal to. So this is equal to 1 times 2 times 3 times 4 times 5 times 6 times 7. I have no idea what that number is. I'm not doing it with a calculator, but I know my answer now. So what factorial? 7 factorial. So this is 7 factorial. So what's n? N is 7. This is a little more challenging one. That's why I wanted to do it with you. Yeah. Because 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 10. That's what that means. So factorials I know are new. Just wanted to go over a couple problems with you with factorials just to get your feet wet a little bit and start thinking through this. And the rule kind of with this unit is do as much as you can without a calculator. But then when the numbers get like ridiculous, use a calculator, okay? But like this, there's no need for a calculator. If we go back to our previous page, can you see any problems that might use factorial that we did together? See number 6? So 6 would be another way to write that. That the answer would be 6 factorial, right? Because that's just 6 times 5 times 4 times 3 times 2 times 1. Could I do that on 7? No. Could I do it on 4? No. How about number 1? What would that be? 3 factorial. We didn't write 3 times 2 times 1, but you multiply by 1, you still get the same thing. So just start, factorials show up a lot when you're counting things. Not all the time, but they do show up quite a few times. We're going to start now talking about the difference between a permutation and a combination. And this is going to be very important that you pay attention to these words and get a sense of the difference between them. I'm going to start by defining a permutation as an arrangement, and a combination you want to think of it as a group. And we'll start to talk about the difference between the two, okay? So if we have, well, they have a little example here. So ABC, BAC, and CAB, they're all the same group, right? In terms of a group, if I'm picking, who's in this group or that group, or who's on this team or that team, A, B, and C, it doesn't matter what order I put them in, it's just a group. So there's one group there, so there's one combination, but there's 3 different ways that you can sort that group or arrange that group. And so we'd say there's 3 permutations, but 1 combination. Okay? And so we'll look at those things. Now here's a fancy formula for permutation, but formulas are shortcuts, and you're not going to have any idea where this came from until we start to. So let's avoid the formula right now and do the problems without. Oftentimes it's easier to do the problems without the formula anyways. And then as we get good at doing problems, we can come back to the formula. Okay, but there it is. That's the formal formula for doing permutations. but that comes after a lot of understanding, okay? And you can see how factorials are used in that. Okay, before we get into these, so one possible thing is talking about rearranging letters. Let me give you a smaller letter. So let's say the letter and. Okay. What else? If I wanted to rearrange those letters, what else could I get? D, N, A. Okay. What else? D, A, N. Sorry, should be a D. N, A, D. A, D, N. N, D, A. Anything else? Okay. This is like a problem that we did already. Which problem did we do that was like this? I was thinking the movie theater one. Right? Remember the movie theater one? We had 6 seats and we're trying to, how many different ways can we place 6 people? And then I brought it down to 3 seats. We were doing this exact thing. And we were saying, well, we got 3 seats, and so there's 3 choices and 2 choices and 1 choice, right? So same thing with and. If I'm going to create a 3-letter word with A, N, D, I have 3 choices and then 2 choices. So although it seems like a different problem, it really is the same kind of logic. So with fraction, how many letters are there? 8 letters. So we're going to, how many different 8-letter words can we make with those letters? There's 8 letters to choose from. And so how many choices can I pick for my first letter? 8. So say I pick the A and I put that down. Now how many choices do I have for my second letter? 7. And so on, right? What does that look like? That's 8 factorial. And then at this point, this is where okay, the numbers are ridiculous. I'm going to use my calculator to figure this one out, okay? So at this point, you could see if your calculator has a factorial button, or you could just type in 8 times 7 all the way down. Both are fine. What are we getting? 40,320. That's a lot of words that you can make out of those letters for this fraction. Okay. Now let me adjust something here. Okay, the word to, that word right there. Got 3 letters. And let's see if we can list out how many different arrangements we can make of that. So what else could we make it? There's 3 letters. Got to use all 3 letters. So OTO, okay, OOT, that's it. Over here I had 3 letters and I can make 6, but now I got 3 letters and I can only make 3. Okay, so, and the reason is because I have repeat letters. So it gets more complicated when you have repeat letters. Okay, if I number my O's, so this is O number 1, this is O number 2. We can start to say, well, if the O's mattered, I could switch O number 1 and O number 2, and then you can see our 6 different options here. But it really doesn't matter which O. So how many different ways can you arrange two things? Two different ways, right? So I could have O1, O2, or I could have O2, O1, right? And so what happens here is if we had the three letters TOO, and we said, well, there's 3 choices and 2 choices and 1 choice, we'd be getting 6, which is too many, right? So then we'd have to say, okay, there's 6, but I have repeats, right? And then the question is, well, how many repeats do I have? Well, O1 and O2, there's only 2 ways to repeat, so then I divide by 2, and I'd end up with, there's 3 possibilities. Okay, before we jump in more, let me give you one more example. Let's say we have A, B, A. Okay, so if I were to handle that one, I would think, okay, I want to create a 4-letter word here out of A, B, A. So I have 4 letters to choose from. Okay, so first I'm going to ignore that 3 of them are identical. Okay, I have 4 to choose from. So 4 times 3 times 2 times 1, which is 12. But 3 of them are the same, right? So I take my 3 A's, those are the ones that are the same, and I ask, well, how many different ways can I rearrange the A1, A2, and A3? One. So I have 3 times 2 times 1 way, so there's 6 ways to rearrange these. If you don't believe me, go ahead and try it. You can go A1, A2, A3, A1, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. Okay, 6 ways. So if I list out all 12 of these, okay, I'm sorry. If I list out all 24 of these, I'm going to be able to split them into groups of 6. And those groups of 6 will be just alike. And so, only 4 ways to get that. Can we list out what the 4 ways are? We got A, B, A, that's one of them. A, B, B, A, B, A, and that's it. Okay, so with that in mind, let's try part C, the word Hawaiian. A lot going on in that word. First of all, how many letters are there? 8 letters, okay? So I know I'm going to go 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. My numerator, there's 8 letters. But if I list, now that's a lot of possibilities. If I were to analyze all those possibilities, would I have any repeats? Yes. So first of all, what letter are we going to pick? That A. So there are 3 A's. Okay, so let's just talk about the repeats with the A's. How many different ways? So let's just look at this word. Out of all those possibilities, this word's going to show up quite a few times. And let's try to figure out how many times would Hawaiian show up. Well, the A's can be like I could switch these 2 A's. It's still the same word. right? I can switch these two A's. How many different ways can I rearrange those three A's? Good. So 3 times 2 times 1 for the A's. But not just A's. What else can I rearrange? There's 2 I's. How many different ways can I rearrange the 2 I's? I could just switch them. That's right. There's only 2 ways. So 2 times 1. Anything else repeating? So 3 times 2 is 6 times 2 is 12. So there would be 12 repeats for every different word. And so this is what my answer is. Okay, so again, I'm going to see how much I could do without a calculator. So 3, 2, 1, gone. 2 times 1, change the 4 to a 2. So I get 8 times 7 times 6, 5 times 2. And then I'll use a calculator probably on that. It's not too bad. It's kind of in between. Should I use a calculator or not? But you can use a calculator on that. What do we get? Anybody get it? Logan, you got it? No. 3,360. So compare that with A. A, we had 8 letters, and we had 40,320. On C, we have 8 letters, but there's only 3,360 different distinguishable words because of the repeats in the letters. We doing okay? That one can get a little complicated, so if you want to back up and ask more questions on that one, you can. Just looking at the different questions here. Let's look at 12. 12 can be a challenging one, and I'll do it with you. How many different ways are there to arrange the letters A, B, C, D so that B is immediately to the right of A? So we have this extra requirement that B has to be exactly to the right of A. Why don't you go ahead and try it first, and then we'll go over it. No, because on that one, B is immediately to the right of A. So like on this one, oh, you have these fine. Yeah, because no, that wouldn't count. You're thinking like circling around. Yeah. No, that wouldn't. What are we getting on 12? 3? 3 is not an answer, huh? Unless I made a mistake. So it's going to be 6. How do we do it? That's the key right there. Glue them together. Think of that as one letter, AB. So instead of thinking of having 4 letters, think of having 3 letters. The AB together is one letter, and so then you have three places instead of 4, and you go 3 times 2 times 1. That's the east. And that's okay. That's how I expected most of you to do it, to write it out. And you got 6 different ways. But The trick here is to think of the two letters being glued together. And that's what, as we work together, we'll learn some of these tricks. Okay. This is not too bad because there's only a few letters. But if I had like 10 letters and put a requirement on, you would not want to list it out, and you'd want to know this trick, right? Okay. So again, everything else on here is part of homework. Let's take a look at the next part. So combination, so permutations, combinations, remember what they mean, right? A permutation is an arrangement, a combination's a group, okay? And part of that, you'll hear some people say the arrangement, the order of things matters. If it's a group, the order doesn't matter. It's just like, who are your friends? It doesn't matter who you list first and second, third. They're your friends, right? It's just it's who's in my group. So combination, the order doesn't matter, and so you're going to have less combinations than you will have permutations. Again, to emphasize the difference here, let's say we have 4 people to choose from, and we're going to pick 3 of them. Okay, we're going to pick 3 of those 4 people to receive first place, second place, and third place. Okay, so how many different ways can we give first place, second place, and third place to those 4 people? Okay, so how many is that? 24? Okay, we're going to list them out because I want to make a point here. So one is A, B, C. Those could be our winners. And whoever I list first is first place. Whoever I list second, second place. Whoever I list third is third place. Okay? So A, B, C could be. What else could happen? A, C, B. A, B, D. Keep them coming. Okay, keep them coming. EDC. What's that? Trying to keep them in order so that the same 3 letters will line up. So I'm trying to be organized here. B, C, A. Sorry, that goes here. No. Where would be B, D, C would be over here. Okay. Bad. What else? E, D, A. Okay. B, C, D. C, A, D. C, D, A. What is it? C, B, A. Almost there. Sorry, that's a D, B, A. D, B, C. Okay. And we said there were 4 choices, 3 choices, and 2 choices, and that's 24. And I have 6 times 4, 24 things here. So these right here are permutations. Okay. Now, if I said out of those 4 people, I just need to pick 3 helpers. Okay. Now it's a group. Like, it doesn't matter who I chose first, second, third. So order doesn't matter. And that's a combination. So how many combinations would I have? We don't have to write anything else out. Everything's here. 4 combinations. Because this right here, all of these would be the same. And all these would be the same group. All these would be the same group. And all these would be the same group. Okay? And so if I were to give this problem and say, and I didn't want to list it all out because that's what we need to figure out. How do we do this without listing all this out? How do I figure out the answer 4? So what I do is this. I first think of it as a permutation. I think 4 times 3 times 2. But then I divide it by, there's 3 things I'm picking. If I pick the same 3 things, how many different ways can I rearrange the same 3 things? You see what I'm doing? And so that would be 3, 2, 1, which is 6. And so 4 times 3 times 2 over 3 times 2 times 1 gives me my 4. You see where this is coming from a little bit? So we're going to try to apply this to some more complicated problems. I'm going to skip the formula stuff, and we'll go back to it. And we'll get back to 14 in a second. So number 15. A basketball coach chooses 5 players from a group of 8 to start the game. Right? How many different groups of starting players are possible? So there's 8 players. You can only choose 5 of the 8. Okay, so then you got to think, well, does it matter what order he picks them in? Like, is it an arrangement? Is it a permutation, or is it a combination where the order doesn't matter? Combination. Okay. So this one's so you first think of it as a permutation. Say the order mattered, and he's going to pick 5 people. So how many choices for the first? See what I'm doing? Okay. But if I were to list out all those ways, we'd have repeats, just like I had repeats right here. Right? And so now we're going to think, well, how many are in each group of repeat? Well, these are groups of 5. Right? So say the group was A, B, C, D, E. There's 5 letters. Those are the 5 people that we chose. Well, that's the same group as E, D, C, B, A. And how many different ways can I arrange these 5? The 5 that I chose. 5 times 4 times 3 times 2 times 1 ways. And now let's see what we could do without a calculator first. So I don't need a calculator on this one. It's just 8 times 7, which is? So if I have 8 players, there are 56 different starting groups that I can make. I'm teaching you to count here. Okay. Try number 17. So there's you're picking 3 dancers, and there's 18 to choose from. So on the top of the fraction, what are we going to do? I'm picking 3. How many choices do I have for my first? And then 17 and 16. Now, if I just multiply those together, why would that be wrong? Because what? Because there would be repeats. This would be the answer if the order mattered. So like if I was giving first place to the first one, second place to the second one, third place to the third one. But it doesn't matter what order I pick the 3, and it just matters who the 3 are, right? That you were chosen to be one of the 3. And so there's some repeats. And so think of a group of 3, and think of how many different ways can I arrange a group of 3, because that's what I picked, and that's what I'm gonna put down here. 3 times 2 times 1, and now I have everything in place to solve this. And here we could use a calculator. And what do we end up with again? 816. Okay. So let's go back and take a look at the formula now. Okay. So the formula is saying, so this is your combination, and what it's really saying is, hey, take your permutation on top and divide it by R factorial is going to be how many different ways you can arrange the group that you chose, right? So this is a number of ways to arrange the group you chose. And so that's what we're making sense of. Now, you can make this more abstract and just have notation, like 10C2. But what this would mean, you just gotta realize what this is saying. So like A would say, there's 10. Think of it as like 10 people, and you're gonna choose 2. And the it's a C for combination, so that tells you it's just a group. Order doesn't matter. And so when you keep that in mind, then you could say, well, okay, if there's 10 people and I'm choosing 2, I have 10 choices for the first and then 9 choices for the second. But because the order doesn't matter, the group of 2 I could rearrange them in 2 times 1 ways. And so then this is going to be 10 times 9 over 2 times 1. So that's 5 times 9, which is 45 different ways. Okay, and so I did that without memorizing any formula, right? I did that just by thinking about what this means and working through it. So these formulas that I'm showing you, you can memorize, but it's probably better for you at first, or maybe all the way through, not even to memorize the formula, but know how to handle the problem. Okay. I think so. You see 45 on the bottom? All right, let's I'll do a few of 14 with you, and then you do the rest of them. So permutation or combination. A, an arrangement of letters in the word math. What's a permutation? Yeah, and what definition did I give you of permutation? It's an arrangement. So if you see the word arrangement, you're going to say it's a what? Permutation. I'm going to put P for permutation, okay? A cleanup committee from 35 students in the class. Is that a permutation? Is that an arrangement? Or is it a combination of group? It's a combination. So I'm going to underline the words that kind of give it away. So arrangement gave it away. That's a permutation. What word gives it away that it's a combination? Committee. Whenever you see the word committee, you're going to go with combination. Okay. The selection of first, second, and third place in a race. That's a permutation. Selecting a photo for a photo book front cover and one for the back cover from a selection of 14 photos. Is there a practical difference between what you put on the front cover and what you put on the back cover? Does it matter? Or could it matter to you? We're talking about real life. Could matter. It will matter, huh? Like somebody like, I want this on the front. Like the yearbook's coming out, right? You just ordered your yearbook for the year. Is it going to matter to them what's on the front cover and what's on the back cover? Probably, right? And so because of that, what would we say D is? Combination or permutation? The permutation, because it does matter. The order of things does matter here. I'll do one more with you. The creation of a telephone number. Combination. So 119 is the same thing as 911. Does the order matter when you're dialing someone's phone number? It does. So it's a permutation. Okay. And then I'll let you finish the rest of those for homework. So let's, I think what can get a little more challenging are the, let's look at 18. 18 can be a challenging one. So committee is made up of 6 members, 3 boys and 3 girls. If 6 boys and 5 girls want to be on the committee, how many different committees are possible? So it's a little more complicated because we've got more things involved. We've got boys and girls. We got how many are starting, like 6 different boys want to be part of it, but we're only choosing 3 of those 6 boys. And then there's 5 girls, but we're only choosing 3 of those 5 girls. A lot more in play here, right? So let's just first answer the boys. Pretend there's no girls. And then we'll answer the girls. Let's do them separately. And then we'll put them together. Okay? So just with boys. If I want to choose 3 of the 6 boys. Now it says committee, so we're thinking combination. Okay? So just for the boys. So there's 6 to pick from, and I'm picking 3. So 6 choices for my first pick, 5 choices for my second pick, 4 choices for my third pick. But once I picked the 3, it did not matter the order that I picked them. So how many different ways can you arrange 3 people? 3, 2, 1. And so we get 20 different ways to choose the boys. Now let's think about the girls. There are 5 girls and I'm picking 3. So my first pick I have 5 choices. My second pick I have 4 choices. My third pick I have 3 choices. But it doesn't matter what order I pick them in. So I can rearrange those 3 people that I chose 3, 2, 1 ways. And so there are 10 different ways to choose girls. So what do you think the final answer is going to be? So there's 20 ways to choose boys, 10 ways to choose girls. You're going to multiply the 20 and the 10 together. And you get 200 different committees. Does that make sense to you, what I did there? Not ask, I want more, if this makes sense to you, the better off you're going to be. There's a lot of thinking We're just starting. This is just the first day. You want the first day to make some sense here. So we're going all the way. So I'll take requests. Do you have any? Yeah. They can go quick once you get them. Or you can maybe want some time to try, just work through them. But if you want me to go 25? The freshman council has 10 members. In how many ways can they select president, vice president, secretary, and treasurer? Who can help me with this one? Number 25. Does the order matter here? It does, because whoever you pick first is president, right? So order matters here, so it's a permutation. So that's it right there. What's the answer? $54. So this is a permutation. So we're not dividing by anything, right? We're just, there's 10 people to choose for president. Once you choose your president, now there's 9 people for vice president, then there's 8 people for secretary, and then 7 people for treasurer. Yeah, that's not 54. That looks better. Just forget my zeros. Anything else you want me to do with you? All right, keep working. If you run into some issues, let me know. We can work through some more.